So good afternoon. So this is the last talk of the day for every one of you. I'm sure you're going to be quite tired. So I'll try to be a bit light and funny. Maybe I'm funny. So anyways, so who's tired? Are you guys tired? I can't see anything. You need to really like wave. Ah! So 3 people only are tired, and everybody else is like happy, energetic. Okay, good. Okay, so there's going to be some interaction here, right? So I need you guys to interact with me. Otherwise, the talk is going to be super boring, and then it's your problem, not mine. So, anyways, let's start with a public announcement, and that's the announcement. So, just so you know, just in case. Anyways, so this talk is about pragmatic development, and it's something that actually came out a number of years ago. The idea that development shouldn't be about metaphysical concepts, but it should be about actually hard measure data. And that was one of the inspirations behind the way our team was built, and it's something that we do constantly. So this talk is going to be about what happens when you measure everything, and you don't stay married to the same technologies, and you don't follow all the evil advice that people give you, but just do what's best as measured. So basically, you don't end up like this, yeah, with Darth Vader marrying you to someone. So that's a stack, right? And whoops, and this is also a stack, Overflow. But I'm going to talk about a bit about our stack, which is a Whisk stack. And everybody asks me, why do you use Windows and why do you use IIS or whatever? Right? Aren't you going to ask me? No. Well, because it works. And it's not a huge issue. But of course, it could be evil. It could be evil if you just do that. And when it's not appropriate to use SQL Server or C#, you keep on using it because everything must be solved like that. So we don't do that, and in fact, over the years, we are surrounded by open source tools, and we use a lot of Linux-based stuff all the time. Everybody, I think, is quite happy, and we are very happy to use what works, right? So. We don't really care. We don't really care about this, and we don't really care, because it's good enough. And this is what we mean by good enough, like a Porsche, right? That's actually one of our developers. Look how happy he is. Well, I would be if I had a Porsche. Anyways, so let's talk a bit about something else. Let's talk a bit about architecture. So how do you do pragmatic architecture? Pragmatically speaking, we are an MVC shop like so many others, and I'm pretty sure that you also use MVC in many cases. Okay, so you didn't see anything. Anyway, so MVC, everybody uses MVC, right? And then it's sold like a really, really simple architecture that has no problems, and everybody knows you have a model, and the model is connected to the view, and then there is a controller that creates the model and the view and puts them together, and blah blah blah. So that's MVC, right? But the actual MVC that we build is this. Yeah, so that's a real world architecture. And why is it built like that? Why is it so complicated? Well, it's complicated because that's what you need when you are at scale, right? If you're building a very simple application, then you're going to have a very simple architecture. But in our case, we need to have MVC, but we also need to have, say, a scheduler, so we can award badges to people. Everybody likes badges, but we need a scheduler to do that. We need caching, right? And caching goes to a different database. We need a lot of things which are shared across. We need to have web sockets, so you can see, when people upvote your answer in real time, it just appears. So the real-world architectures are much more complicated, right? We still say that we do MVC, but actually we are not married to it, and we do something which is much more complicated. So, interactive bit. So coding style is something that people debate a lot on, right? So people debate, what's the correct way of doing this using patterns or using functional styles, and should I use a discriminated union here, and so on. And we also debate all these things. We also debate all these things, of course, all the time. But we tend to be very, very pragmatic. So we tend to do whatever works best. And so I just pulled out little bits of our code, and I would like you to guess the style. Okay? So we start with something maybe simple. So to show you what I mean by this, and see if you can guess what we did there. Okay? Okay. So this is an example. As you can see, these are the badges. We were talking about the badges. And then some badges have different behaviors, right? Some badges need to be connected to SQL. Some badges need to be connected maybe to APIs, like, for example, chat-based badges need to connect to the chat server to make sure that people did whatever they need to do to get a badge. But some others need to see what questions you answered, so they need to go to the database. And some others need to actually work in real time. So, for example, we have an help page in which we explain to the new users what they need to do in order to use the site. And then when they read it, they get the first badge. That, of course, can't be awarded 1 hour later. It needs to be awarded in real time. So that's a different kind of badge. And then, if you look at the SQL badges, each specific SQL badge will have a different code, right? A different behavior, different SQL that gets executed. So in this case, it's appropriate to use a object-oriented style, right? You can see the tree of objects here. Inheritance. So object-oriented, but sometimes we do code like this. Can you understand what this code does? And can you see what style it is? No? Anyone? Could be functional? Yeah? There are a lot of lambdas there. There are a lot of dotted notation. Sequence of methods, method chaining, and so on. There are enumerables, which are very, very functional, and so on. So in some cases, we do functional programming. In other cases, we do stuff like this. So we decorate methods with a lot of stuff. Do you know what that is? Aspect-oriented programming, anyone? No? Okay. So this aspect-oriented programming. Aspect-oriented programming is a kind of programming in which you define some behaviors that you want to share across the many different situations. And then you introduce those behaviors by decorating methods. So typically in this case, we want to track this page, which is one of the main pages of the site. We want to track when users go there, what they were looking for. And so we introduced this track newsletter, sorry, completely wrong. That's to track when people actually click on our newsletter. Because if nobody looks at it, then we'll take it away. Other stuff is getting crazier and crazier here. This is basically batch processing, right? It's procedural, so-called procedural programming, something from probably all you are young and you will never have seen this, but in the 80s, maybe it was quite common to write procedural stuff. And why do we use that? We use that because this is actually appropriate when you're running a schedule. So when you're running a schedule, you need to want to do a bunch of things every hour, for example. This actually gets run every hour. And so it goes through each step, and it does it separately, and you get a lot of procedure. So it's procedural programming. In our cases, we get stuff like this. Do you know what that is? What could emit be? Nope. But good guess, but no. This is metaprogramming. So we are actually outputting code from code. Right? It's like a compiler. We are creating code, or we are creating methods at runtime that are more efficient than generic methods that we could write. So for example, this runs when you're trying to see a list of questions, right? So you go on the homepage of the site, and you want to see only JavaScript questions. And you can do that. You can filter by a tag. What happens there is that there is a poor piece of code, this one, that has to go through all the questions at some point and filter out only the ones with the JavaScript tags. So the problem is that we have around 10 million questions, and we got millions of users. So this is a lot of work. And in order to make it as fast as possible, we need to basically generate the code on demand, so we don't check every line. Like we can avoid cases in which, for example, let's say you have the same code that checks whether you are on the home page without JavaScript, on the home page with the JavaScript filter. So you will have some code that says, if the filter is set, then match it. And that is too slow. So what we do is we create two methods, one that just doesn't have any filter, and one that always checks, right? And these are created by writing the code in real time. Okay, this is crazy stuff, but we need to do it because it's actually necessary. We can prove with the numbers that this is actually making the code maybe 20% faster. So we do that. Other crazy stuff is stuff like this. So what's the point of creating, interned arrays of characters? I mean, who cares, right? And unfortunately, we have to care. So these are used in the .NET framework. So when you want to split a string, which is a very common operation, you need to split it on you have to say, split it on this array of characters. And of course, that's a bad design in the .NET framework, right? Because if you create an array, the array is always instantiated. So you're creating instances. And we hate creating instances because they create a lot of garbage collection. And we don't want to have garbage collection because it makes the page slower. So what we do is we pre-create these arrays with all the craziest ways that we found in the code to split, and then we just call this static property. Another example of crazy stuff that we have to do to be pragmatic is stuff like this. I mean, this is complicated code, complicated to read, but what it does is looks for a token in a string, and it's a common operation. Of course, the framework also has the same function, but we re-implemented it because it was more efficient to do so. So on one hand, we debate, should we do this with object-oriented design, or should we do this with functional development? But we also debate, should we re-implement this function of the .NET framework? And sometimes we actually have to. So Donald Knuth once said that premature optimization is the root of all evil, right? Did you guys ever heard of this? It's very famous. Only 3 people, come on. I'm sure that you have heard of it, yes. Okay, fine, right? No. So yes, it's right and it's correct, and I will never say that null not is not correct. But you know, fact-based optimization is actually very important, right? The problem is not that it's premature. What does premature optimization mean at all, right? When is optimization premature, and when is optimization just the right time? So do it now because it's not evil. Because every time someone told me that, it was always to tell me, oh, it's not the right time to optimize, right? And I can give you the answer now. And the answer is that optimization is not premature when you actually measure and you can prove it with numbers that you need to optimize something, right? So you optimize something based on numbers and you pragmatic development, and you do the optimization in a way which makes this guy happy and this guy happy too. So how do we do that? So we use a series of tools. And fortunately, we have an internet connection, so I can actually show you, hopefully, how they work. So the first tool that I can show you is a tool called Mini Profiler. Are you guys familiar with it? Can you guys read? Yes? I mean, I know in life you can read, but can you read the screen? Okay, so this is Stack Overflow. It's a normal Stack Overflow screen, except I'm a developer, a Stack Overflow, of course, and I have extra information on it. And the extra information is those numbers here. Can you see them here? Yeah, so click in there, and this happens for every page that I visit. There is a profiler running in real time on the question, on the page that is being displayed. So when I go to a page and it's low, I can know exactly what's going on. You know, I can see the profiling of the page. So this is all the steps that are needed to create this, and all the milliseconds it takes. I can see how much time is spent on SQL Server. I can see how much time is spent on Redis fetching stuff for the cache, and also other tools that we have. So for example, if we are making an external web request, we are also storing that. And there's a bunch of other stuff. For example, if I see that SQL is a problem, I can click on it. I can see a list of all the SQL statements that have been asked on that page. I can see that, for example, this query is getting my account from the database, and other queries are happening here. And for each one, I can see how long it took. So if something has gone wrong in a query, I can know exactly what's gone wrong without needing to replicate, because it's there already. And I can demonstrate that something has got broken. So lots of information there. And this tool, by the way, is available as open source. You can use it with .NET, with Ruby, with Node.js, and so on. And I strongly suggest that you actually profile everything that you do, because there is so much information that we get out of this. What's interesting here is that the way this works is in an interesting way. So in order not to be intrusive in your page, it doesn't really append anything to your page. So what it does is it puts stuff inside the HTTP headers. And in practice, puts an ID in the HTTP headers, and then there is some code that is loaded asynchronously that pulls out of the application the whole profiling session. So it's interesting because stuff goes in the headers, and we extended that, so more stuff goes in our headers. You won't see it if you look at the headers on your own requests, but it's a way that we use so we can communicate between the web servers and the load balancer what's going on. And once you do that, you can put together with the list of requests that you get from the internet all the timings, right? So wouldn't it be great if you had something like this? For example, something that lets you run queries on the logs, right? So we have this tool called HAProxy logs that allows you to query the logs. So these logs are live logs, and I can get. Hopefully, there's nothing private in here, but you never know. But I can select the last 100 requests. This is real-time data, and you can see when that happened and all the data. And in here, that's the important bit. You have all the numbers or all the roll-ups that were there, right? So I know, for example, that the request spent 9 milliseconds in SQL. Right, and this allows you to do things like, you can do maybe select. You can select, for example, the average SQL time spent in SQL, or the average time spent in Redis for a particular set of queries, right? So, for example, so this gets the top 100. The top 100 queries for maybe question show, which is the most popular page that we have. Questions show. Hopefully, I wrote it the right way. Let me see. I surely have one here. Here it is. Questions show. Yep. And of course, it takes a little bit because it needs to hit the index. But then you can get all the data for this particular page, or you can do that for a particular user. For example, if a user comes on our site and tells us. For example, that they experienced a problem, and if they tell us when, we can go look in the logs and query them and actually understand what went wrong by looking at the actual data that was. Oh, I just went back. I need 2 backslash. Thanks. There you go. Well, now it's gone. Well, maybe it's faster, right? Because it's going to hit some results. There you go. And you can see that these are all comparable numbers. Of course, that's what I meant to show. You can see that, for example, this one was slower. Something wrong went there. Or it's for Google, then it's probably likely 200th page or something. Then it's out of cache. So that's another tool. Again, this tool is also open sourced. It's called Stack Exchange Data Explorer. And basically, it works by plugging into a database and let you run query via web on that database. And also, if you want to do cool stuff, you can go on this site here, data.stackexchange.com. And there, you can actually run queries against our data. This data is maybe late by a few minutes with respect to the actual sites, but you can do cool stuff, right? So you can say, okay, select top 100 star. This is too small, right? From posts where title like what? Ordered by score. And this, ask me, who am I? Of course, I'm a human being. Hopefully I didn't forget some slashes this time. There you go. And these are, so you can get answers like this, right? So these are our top questions, which start by what, the title starts by what, and sorted by score. So there is a 5,782 points question, and I have no clue what it is. So if I want to look at it, I can do this as post link, and it should work, hopefully. And it doesn't because I need to do this. Sorry. Post link. There we go. And it's this. What is the correct JSON content type? In case you wanted to know, 6,000 people really wanted to know. And the answer is application JavaScript. There you go. Didn't know that. Upvote. Okay, so other tools. Let me bore you a bit more. Another example? What would you like to know? No, I can only vote it up once. I showed it to someone that was, they asked me outside, so I just reused the same example here, but it's the first time I do it. Second. Other tools. This tool here, status. I showed it also in another talk, but this is live. And so this tells us all the load and all the performance on our web servers. I can confirm that we still have 9 running web servers, in case you wondered. But there are more interesting things from the point of view of the pragmatic developer. And the 2 things I look at are these 2 views. This is one, the red one. These are the exceptions. So when something goes wrong, a lot of questions, a lot of errors appear here. So this is what you want to look at as a developer. And as you can see, these are not really, they look like frightening, but to the expert eye, these are not very frightening errors. These are just timeouts, but when you have a network-based infrastructure, timeouts happen all the time, and there's nothing you can do about it. So these are really known errors for us. And the other thing that we really look at is this, right? This is our SQL Server monitoring tool, and it tells you what SQL Server is doing, right? You can use it for any database, of course, but it's very interesting in our case for this, and it tells us, for example, stuff like this query here, select, well, let's see, yeah, select post type ID and some when close date, blah, 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 blah. This is a query that takes a long time to run. It takes 119 million microseconds, so 2 minutes to run. Is probably not run very often. Yeah, 67 times only. But is the thing that has taken more time overall on our SQL Server. And if you go down this list, you can see all that is performing and what is not performing, and you can actually fix what's broken, right? And since this is actually the main use case, so what we do, with this tool, you can actually go in and see the query plan. You can see what's taking so long. In this case, nothing. It's just a complicated query. Well, that happens, right? Because we have this tool. Right, because we have this tool, we can go in order and see, okay, what do we need to optimize today? And you look down and see, okay, this one also doesn't have any problem. But of course, because you fix it, because a lot of problems have been fixed. And if a query plan is actually broken and needs to be recalculated by SQL Server, do you guys know what query plans are? Too technical? Well, nobody moves their hands, so wave. No. Okay, some people do. Okay, but anyway, so query plans are basically what a database thinks, right? So you say, I want to get the top 100 entries in our logs where the route name is query is question show, right? So what it does, it looks internally and it tries to compile this SQL into something which actually is executable. So there are some basic operations that SQL Server can perform, and it tries to combine them in a way that actually does what you want. So these are the basic operation, these blocks here, and of course, depending on how you write your code and how you configure your SQL Server, you want to do it so SQL Server uses the least expensive things, right? And for example, I can give you a very, very simple example is when I wrote the wrong route in the query before, it took a long time, right? But then when I wrote the right one, it took a very short time. And the reason is that it's using indexes, right? And you can see that here, and this is a different query, of course, but this query is using indexes. So it's looking for something that exists. And when it finds something that exists, it's really, really fast. When it doesn't find something that exists, it has to scan the whole table. So it takes a long, long time. And so we look for these things. And if something is broken, we can go and fix it or nuke it. So this red thing here removes the plan. Yeah, because what happens is, in some cases, there are many possible ways of putting together a query. And so SQL Server does the best guess. But sometimes the best guess is not a good guess. Right? Sometimes maybe the user that is actually making that query is a user that has answered so many questions that it skews all the statistics of SQL Server. So it looks like SQL Server looks at this user and says, okay, this user said answered 20,000 questions. So every user, obviously, has answered 20,000 questions. So it takes that into account. And it creates a crappy query plan. And we call this the Jon Skeet problem. So if Jon Skeet is a top user, and he actually answered 0.3% of our, or 3%, I don't know, a huge number of questions, and if he's the first one, or someone like him is the first one that hits some query, maybe they can skew the compilation. So we need to go in and press this red button and have SQL Server recalculated. So again, this is another way in which we actually monitor stuff. Another way is instead is much more useful. For example, is useful for a million things, but I find it particularly useful because one of our enemies, as I was saying before, is instances, right? If we create too many instances, like one too many per page, or too many, maybe by doing functional programming in the wrong place. So what happens is that our servers clog with allocations, right? Every page view allocates 1,000 objects, and then multiply that by the number of page views that we have, and we have a slight memory problem there. And so what we do is we monitor garbage collections, which is something which is not really easy to see in your code. You can't really easily scan your code and see, I'm creating an instance here. It's pretty hard, but you can see the consequences, right? And so we have this tool called Boson that is a tool to examine the historical, the history of events. So, for example, if you want to monitor garbage collection, you can say, show me the last hour of garbage collection. It's going to tell you, you're going to do a graph of it. For example, in this case would be maybe C#, .NET, memory, garbage collection, time. And there's a gauge. I want to see, yeah, this should work. Hopefully, I never write these things, and sometimes they don't work. So cross our fingers. It's not working. Okay. Let's see average maybe. Well, anyways, I hope it works. If it works, you're going to see it doesn't. Okay, so you're going to see a graph of the time spent in garbage collection, which of course is very, very useful if you're trying to exactly do that, to minimize it. Yeah, so I have it here because I'm smart and I have a backup. Here you go. It looks like this when it works. right? And you can do all sorts of analysis with that. You can see, other kinds of events. You can see, for example, how many exceptions are there, or how many disconnects are there, and so on. So this is very useful for SREs, but it's also very useful for us. And all these tools are open source. And if you go on GitHub/Stack Exchange, you're going to find all of them, or at least a link to them. You just need to remember the names, I guess. I strongly encourage you to use them because they are the basics. So measure everything, time everything, use the right tools that give you the right information, and that allows you to write the right kind of code. Another example of pragmatism is this, and we are on the wrong page. Okay, so this is the basic way in which we do deployments, right? And I'm sure that it's very, very similar to many of you. Yeah, so what we have is, we have Git, we use Git, and then, when something goes on Git, it gets deployed on a development server. Once we're happy with it, one click and we build, and it gets deployed on a canary site. This is something that maybe larger sites tend to do because we need to evaluate scale. So we just push it to a couple of web servers to make sure they don't break. And then we push it out to everyone else. So in theory, most things are very, very simple, right? And this is the classic, textbook kind of deployment. However, it happens that we want to make sure that we can not only roll back the change by rolling back Git, but we also want to have switches on each web server so we can turn on and turn off stuff on different servers. It makes sense, right? So there is three ways to deploy, and then each server can be configured to have a feature switch that has something on and off because we actually need it, right? There is stuff that only works, that's only enabled on Stack Overflow, and stuff that is enabled everywhere but not on Stack Overflow. And we have 150 sites, and they all are slightly different from each other. So lots of switches. This works until you have teams. And when you have sub-teams of maybe 2 or 3 people working on a single feature, they can't really put their partial development in the main branch. So they work on a branch, and again, they have their own build and their own server, and then it's merged back into Origin and so on. But that's not enough, right? Because what happens is that there are some features that you can only test on Stack Overflow. For example, one of the things I'm doing is I'm changing the Stack Overflow homepage. And I'm trying to optimize the homepage so people can find more easily questions to answer, which is something that our users want to do a lot. The problem with that is that if you need to measure performance, the only way you can actually do it is do it on real Stack Overflow. If you want to measure how users use your page, you can only do it on Stack Overflow. On the other hand, you're changing the homepage of Stack Overflow, so it's something you don't just want to do it and test. It's something you want to do it on a limited scale first. So the way we do it is we have an alpha channel. So if you want, you can participate in an alpha channel, and you can see the next version of Stack Overflow. But that means that every site now has 2 versions. Has the normal version and the alpha-enabled version. So even when we started for a simple thing, when we have real-world problems, and factual problems that you need to solve, then you end up building something very complicated but very functional. There's nothing wrong with it. That's what pragmatism is. Prove something and then do it. So other stuff. Okay, a little break here. So every April, the RFC committees, RFCs are how the internet is built, right? So there's documents that come out, they get discussed, and new protocols come out of it, like HTTP, for example. And every April 1st, they come out with some completely ridiculous RFC. And one of these was this one. was saying, okay, we can run the internet over carrier pigeons. So you put your message in a pigeon and you send it off, and it just flies, fluff, 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 goes to someone else, he opens it up, I received a message. Right? It sounds really stupid and silly, but someone actually did it, and they actually ran it. So as you can see, it works, and there's a ping, and the ping is responding. Look at the time. It took a long time, like 5 hours to ping a server, but you can build it. So RFCs are an important thing, and we use them all the time. We have an internal system of RFCs in which anybody can promote a change for Stack Overflow or for our company. And that's very important because it enables a number of things. It enables everybody to speak their voice. But it disables a lot of bad thinking. So that's a very pragmatic thing to do. So the way you build an RFC is not simply saying, I want to do this. Everybody's going to say no. The way you build an RFC is you have a problem statement in which you say, okay, this is the problem I want to solve, right? And I can demonstrate that. And this is the solution. Maybe it will work, maybe it won't, but we can discuss it, and we can actually measure it, right? So RFCs are important. They allow people to speak their minds, propose stuff, propose a problem that needs solving, which we can all agree on, and a way to measure it, measure success. The key there is this one, right? Citation needed. We are a fact-based company. So we use all these tools, and some of the tools I've shown you, they're not only used by developers or sysadmins, but they're also used by other people, like our community managers or our product managers. They use them. They run their own SQL queries to actually understand, what the numbers are. Is it true that people, go to one page and then never go to the next page? So you can measure that by looking at the logs, and they do that to actually prove that we need to change the page because nobody's clicking through. So that's very important. And this allows anybody to make a case for changing a page, for example. Of course, we do the same. We have the same kind of openness with our community. So many of our developers are many developers are engaged with us on a site called meta.stackexchange, which is like Stack Overflow, but is about Stack Overflow. So it's about our software. And that's where we present stuff. For example, you can get very insightful comments, right? So after 6 months of work, I presented the new navigation to the guys on Meta, and this is the kind of response I got. I looked at it at 10 minutes, and I can't understand it, so it must be bad, right? Thank you very much. And so we engage with them a lot, right? Another thing we do is we do a lot of pairing, right? But it's a different kind of pairing. It's a pairing that is not of two developers. Maybe it's a developer and a designer, or two different people. And that is because different people catch mistakes in a different way, right? They see much better there. So in conclusion, so there are three main things I want to say. So the first one is this one, right? Not a unicorn, but development needs to be multicultural. What does that mean? It means that you can't really have a successful company that does one thing, right? Oh, we always use punch cards. Let's use punch cards for the next 50 years. That doesn't work anymore. Let's use Java for the next 50 years and write awful, pattern-based code. Maybe it works in a niche, but you need to diversify. You need to understand that if you want to use pragmatism, if you look at the numbers, they will tell you that not all code is best written that way. Some code, yes, but not all of it. So measure it. Another stuff that is important is what is called pluralistic management. So this is a wonderful drawing by our CEO, Jon Skeet. And this is how he sees the company. Is really terrible at drawing, but as you can see, it looks like a normal org chart, right? Does your company have a org chart? You know what it is? You know, a CEO on top, and then all the other managers, and then at the bottom, the developers, like the slaves. Our company is like turned around, right? So if you look at the top, you can see actually there are the developers, top left, and then sales and marketing, which is represented as a big Godzilla thing. But on top, there are all the people that actually do stuff. And everybody else is under them. The reason is we don't have a culture by which your manager tells you what to do. You tell your manager what you need. And your manager tell their manager what they need. And so it's a culture of helping people. It's not a culture of commanding people. We are not an army, right? We don't have generals and corporals and soldiers. We are the way around. It's called pluralistic management. It's actually a serious thing, sort of. And it works really, really well with Agile. It works really, really well with pragmatism. Why? Because pragmatism enables it, right? When you speak based on the numbers and the evidence and looking at the facts instead of saying whatever, that already disables a lot of management kind of diktat, right? Your manager can't come to you and say you should change your site like this and make it like that. Nobody can tell you that because it's just an opinion and nobody cares. What people care about is, okay, prove it to me, right? Prove it with the numbers. And then we can debate the numbers. And if the numbers are right, then it's fine. If my manager tells me to do something, it's fine. I'll do it. And I'll do it if someone else tells me as well. As long as they are right and they can prove it in numbers, that's how it is. That's how a company works. It's many different people with different ideas, with different histories. I'm Italian, and my boss is Canadian living in the US, and then my friend is from Slovenia, and we all work together. We have people of different genders, different sexual orientations, colors of the skins, and so on. And that's all as variety and all as idea, but you need to have this pragmatism that allows everybody to cooperate. The last thing is jobs, right? This reflects also in our sort of offering. We make money, and the thing that powers Stack Overflow and gives us the money to actually be alive is that we have a job board. And that is actually a good thing because for developers, we want to get you a job which is better than the one you have. And we know a lot about you, right? We know what kind of questions you like and you read, and so we know what you know. And we can give you a better job. The only thing that we need, because we'll never spam you or sell you out or do anything like that, is you need to create a profile if you're looking for a job. And all the numbers are there. If you're a registered user, you can go to your profile and you can download what we know about you. And we can show that maybe we think you are a C# developer or a Java developer, that you are interested in this and that. Based on your activity, you can opt out and delete all the stuff, or you can look at it. And most of our users are actually very happy to look at it and to see if it actually matches what they are or not. So if you're interested in this stuff, tomorrow I'm going to be at our stand. We have a stand here, and we can chat about our careers website. We can chat about Stack Overflow, pragmatism. We can chat about, what can we chat about? Whatever you want. There are free t-shirts, so come early because the t-shirts go away like crazy. And as I was telling you, I'm working on the new homepage. And we have a prototype, but I'm not ready to show it to the whole Stack Overflow, but I would love to show it to you. So if you come tomorrow at our stand, I would really, really like 5 minutes of your time so you can tell me what you think of it. And that's it. So thank you very much.